In the video on solubility, I draw little pictures of sodium and chloride ions when sodium chloride dissolves or dissociates into water. So this is sodium and this is chloride. And my simple brain, when I looked at it, I said, okay, how should I draw these things? I said, well, they're in the same period, and sodium is a group 1 element. It's alkali. It's an alkali metal, while chlorine is a halogen. So chlorine is going to have a smaller atomic radius. And the logic there, just to review from the atomic table trends, is that they both of their valence electrons are in the third shell. Sodium only has 11 protons pulling in the center, has 11 in the center, and it has only 1 electron out there in its valence shell. So the attraction isn't as strong as the case of chloride, which has 17 protons in the center. And then, so it will, although it has more valence electrons, it has 7 of them. What is that? 1, 6, 7. These protons are going to have a stronger attraction on them. And so if you just look at the trend in the periodic table, you'd expect the sodium neutral atom to be bigger than the chloride neutral atom, because this guy has more protons pulling everything in. And that's how I drew the ions in that video. I said, oh, well, when I dissociate in water, I'll have a big sodium ion and a smaller chlorine ion, which is incorrect. Because think about, and this was pointed out to me by one of the viewers, and they're correct, and I should have realized this. What happens when you ionize these things? This guy will lose an electron, right? He gives the electron to this guy. So his electron configuration is actually going to look a lot more like neons. He now will have no electrons in that third shell, in the third energy state. So now he's going to have an atomic radius that's actually much more similar to neons here, right? Because he's going to have filled up the second shell. So actually the sodium ion, this is completely incorrect. The sodium ion is going to have an atomic radius not that different than neon. Actually, it'll be even a little smaller than neon because it has the same electron configuration, but it has 1 more proton. So the sodium ion is actually going to be smaller because it gets rid of the electron in that third shell. And the chlorine ion, cation, gained an electron. So it's completely completed its third shell. So here you have where the chlorine ion is going to be bigger. So in that solubility video, I should have actually switched the places between the sodium and the chlorine, at least in size-wise. And of course, I show how they dissociate in water, and this would be attracted to the oxygen end of the water, and you have the hydrogen ends and all that. But you can watch the solubility for that video for that. It doesn't change the real takeaway from the video, but I think this is a really interesting point that brings up that when you ionize these neutral atoms, it can significantly change, especially significantly change their relative atomic sizes. Anyway, hopefully you found that interesting.